My name is Oleg Zhurakowski. I'm an engineer at Hortonworks. And I also have here with me Vinod, since there is a yarn in the title. In case if there is any deep questions on yarn, he'll be able to help me out. So, but what I've been doing at Hortonworks lately is I spent about good last 8 months playing with Spark and trying to see various different ways of how it could be integrated, especially in the realm of some of our clients who are using Spark and some of the issues and some of the problems they faced and how to address them and so on and so forth. So, and the purpose of this talk is to primarily share some of my experiences. So I'm a developer, so there's going to be some code. That's why I have a computer with me. So I hope you guys are at least capable of reading code, right? So. Quick show of hands, how many of you are Spark users today? Fair amount. And how many of you are here to, learn about Spark, kind of a brand new thing? Even more. Okay, good. So I was just trying to figure out, am I going to give you too much or am I going to give you too little? So I think I got the right material. So let's begin. So what is Spark? Spark is a general engine for data processing. And the reason why I skipped the large scale and all the other buzzwords, because when you look at the API that you see on the screen, and again, I'll show you back when we switch to Eclipse, there's nothing big or small in this API. The API simply allows you to define the type of process, the type of transformation, the type of filtering, and other pipeline operations that you want to perform on the data, right? If the data is large, right, then it's the underlying system's responsibility to distribute and properly and manage it and so on and so forth. So, and this is one of the interesting points about Spark, because that's what you see, right? If I were to ask you a question, what is your primary interest in Spark? How would you? Can somebody try to answer that? Like, why are you interested in Spark? I'm sorry? Unified API. Well, Java had API from MapReduce. Okay, so you like the API, right? You like the. Okay, good. So you like the API, and I like it too, right? So of course, when you look at this code that expresses your typical word count, and you look at 50, 60 lines of code to do it in Java in the old MapReduce API, of course, there's no competition, right? So this is definitely a better option, right? So, and this is really a primary attraction of Spark right now, is because at the end of the day, we have all different, variety of different products that work out of the box. But in the end of the day, it comes down to, when it comes to customization and specialization, it gets down to the developer. We have to write some code. And we want to be able to use the API that allows us to do it simpler than, the way we did it before. So that's what kind of Spark in a nutshell. So getting a little deeper, these are probably the most important, slide of the entire presentation, because it kind of shows you the internal architecture of Spark. So if you kind of start digging into the Spark, you will quickly realize that there is 3 main architectural abstractions. The first one is the one that we just saw, the API itself, right? Then we have Spark Compiler Optimizer. What is it? So when you look at the API, obviously you chain certain operations together and something has to happen, right? So something has to translate these operations into tasks. Something has to distribute those tasks, and there's a lot of things, there are a lot of moving parts in there that has to translate it in something that the big data system, whether it's the Yarn, whether it's the Spark Native, whether it's the Mesos, can understand and process, right? So, and that's what the Spark Compiler Optimizer does. It assembles, it translates your API into an executable tasks. That's essentially what it is. And the third one is the DAG runtime execution environment, which Spark comes with its own native execution environment. But the fact that it is a separate abstraction, you can easily plug in your own execution environment, and we'll talk about various different reasons why would you want to do that. Okay? So again, to quickly summarize, we have API, we have compiler optimizer, and then we have execution environment. So getting a little deeper and kind of giving you more details, so we have, again, to summarize, we have API, we have execution engine, and we have various different libraries that are already developed on top of Spark. MLlib is one of them, but if any one of you follow the Spark Summit, there's a lot of interesting products that were developed on top of Spark, so the ecosystem is growing and the community is very perceptive of Spark. Okay? So RDD is probably the main abstraction of Spark, resilient distributed data set. Quick question, just to give you a better understanding of RDD. How many of you start looking into Java 8 already? So in Java 8, there is a very interesting new API called streams, right? So for those of you who already looked at streams, you can kind of draw the parallel that stream is RDD, RDD is stream. It's not exactly true, but for all intents and purposes, it is true for this discussion, right? So, RDD defines operations on the data set. And for those of you who are familiar with Scala, the RDD API looks very similar. Basically, it was modeled over a Scala collection API, right? So in other words, that's actually another good thing about Spark is because for a lot of cases, the learning curve, for those who are already familiar with Scala, the learning curve is not that great because some of the abstractions are very similar to what you're already familiar with the Scala collections. So it defines two types of operations, transformations and actions. I don't really like the word transformation because filter is not really transformation. So, I'd rather use the terminology used in streams, which is the intermediate and the terminal operations, right? So, for example, when you say flat map, map, and so on and so forth, those are all intermediate operations. And nothing will be triggered, nothing will be executed. You can chain them up as much as you want, and nothing will happen until you finish your pipeline with terminal operation. And there's several terminal operations. We'll look at some of them, collect, save as text file, and so on and so forth. So, so that's pretty much how you look at Spark. And again, getting a little deeper, so we have a Spark driver, which is the client-side application. That's where you kind of write your code. Then we have a Spark context, which basically acts as a main delegate between you, the developer, and the target execution environment, right? And then there's a cluster managers, and Spark integrates with a variety of them already out of the box. So it integrates with Yarn, it integrates with Mesos, and obviously it provides their own Spark native Akka cluster to perform distributed computations. And finally, the executors, those tasks that the compiler optimizer creates, those are the worker bees. Those are the ones that are being distributed across your entire cluster, and that's the actual executable code, which encapsulates some of the functionality that you've defined. Okay? So, demo, that quick. So let's look at the, your quintessential sort of a word count, right? So I've deliberately stacked it up. Can you guys see the code, or should I make it bigger? Bigger? Okay. How about this? Better? Guys in the back? Good? All right. So, so what we see here is, so we created a source file, right? Or I'm sorry, we created a source RDD. So in other words, there's actually two ways. So Spark exposes, so there's the concept of RDD, you can create your own RDDs, you can extend them, and we're going to talk about this in a minute. But Spark also provides a couple of factory methods to create RDDs. So for very common operations where you want to point to a file, right? So Spark exposes various different factory methods. For like, in this case, I'm using text file because I'm pointing to a text file, but you can also, if you're operating on Hadoop, there's a sequence file and a new Hadoop file if you want to completely define your input formats and everything else. So, and as you can see in the commented code, there's also a way to source your RDD from a collection. And so in other words, you can define collection here, right here at the client, and Spark will slice it, distributes it, and a lot of times it's not primarily for the operations on a large data, it's primarily for the computations like for MLlib where you the source of the data is relatively small, but you have to distribute it because the computation is going to be much, much more complex. And therefore, it's like Monte Carlo simulation, a typical case where you have very small initial data, but what it's going to compute is going to be enormous amount of data. So this is where you would use something like parallelize and provide the initial collection. So once we got that, so now we can construct our pipeline. And again, for those of you familiar with either streams or Scala collections, it's very familiar methods, flat map. We're going to split the line and create the traversable of tokens, in this case words. Then we're going to map it to the key value pairs, and then we're going to do reduce by key because we have key value pairs, right? So, and then we're going to execute collect. And at this point of time, we're going to get an array of arrays for each partition that's been written, right? So now if you look at this code, initial view is obviously, it's much better than the old MapReduce, right? But let's look at it a little closely and see if there's any problems with this code. I mean, it runs perfectly fine. There's no issues. It compiles, it runs. Who can tell me if there's any problems? Architectural problems. Let's look at the first line. So you have a text file, right? So what does it do? It's going to create you a source RDD, right? With the RDD type or element type is string, right? But if you look at the way the code is written right now, can I possibly take the same pipeline and execute it against a sequence file or a collection or anything, any other source system? So what I'm trying to point out here is that one of the sort of areas, so it's convenient for the developer because it can quickly point to a particular source. But if you look at it as sort of a production code, that's not really production ready. This is not really enterprisey. The reason being because you're really coupling your pipeline, your computation coupling to the actual source. But if you look at the computation itself, there's nothing specific here in a text file, to a text file. You could source it from a collection, you could source it from a sequence file, you could source it from an org file, from Parquet, from whatever, right? As long as the contract satisfies that the RDD, the initial RDD is going to be with elements of type string, the rest of the pipeline will apply fine, right? So in other words, while these factory methods are a convenience for the developer, especially in the early stages of the development, it obviously asking for some kind of a factory class where you can say, listen, here's my factory, I'm going to bootstrap my initial RDD from some configuration, so my pipeline actually is compliant with the contract of element of type string rather than source being text file. Okay? Now, there's more. Let's look at the last line of code. Collect. Right? So what is it going to do? It's going to bring all that data into memory. Well, if I have a few kilobytes of data, that's fine, right? But if I have a few terabytes or petabytes or whatever the other bytes, right, it may not work. And so again, if you look at the code looks fine, but now the actual data, the size of the data can influence how this code may behave, right? And again, we can continue. There's a few extra things, but I just want to make sure I point out these things for you. And we'll switch to back to the presentation. So actually, before I move on, any questions so far? Yes?
What about the reduce by key? Because in MapReduce, you need to have all the data before you can start reducing.
So the question is, what about, I'm not really understanding, so.
In MapReduce, you have to wait for all your mappers to be completed, and afterwards the data is streamed to the reducers where it's sorted and.
Right. So actually, good question. I'm going to switch to the code again, and let's talk about this. So what the question was, so basically in the MapReduce, you kind of have to wait till all the mappers are finished, and there are some optimizations here and there, but reality is you have to wait for all the mappers to finish before you begin the reduce phase. Well, that's fine. That still applies. The thing is that what's interesting is that in old MapReduce code, you have to physically think about mapper and reducer. You as a developer have to be aware of these particular structures and concepts within the big data, right? But here, think about it. Do you really need to care about this? What if there's a framework out there? What if there's an API that will be able to determine automatically when to split? Because what you're talking about is the two stages, right? So in this particular case, I mean, I can argue that there are cases where you want to be aware of stages, but 90% of the time you actually don't, because you just want to think in terms of how you want to process the data, right? And in this case, you simply say flat map, map reduced by key. But going back to compiler optimizer, what that component is going to do, it's actually going to translate this code and see, okay, well, I have it reduced by a key. So what it's going to do is going to create the first stage, which consists of a flat map and map, and will end with a shuffle writer. We'll talk about that in a minute as well, right? And now it's going to interact with the shuffle mechanism of whatever target system you're using, whether it's a Spark native, whether it's Mesos, or whether it's Yarn, right? And then it's going to construct the second stage, which will begin with basically with the reduced by key. So that's kind of answers your question, right? But as a developer, from the API perspective, you don't actually see that. Like I said, for 90% of the cases, it's a good thing. Any more questions? All right. So Spark a lot of times being presented as a sort of a product, right? And it is. But again, when it comes to the developer, I also like to look at something like Spark as a framework, because it is a framework. And as a framework that, once you understand it, once you see various different layers, you can say, listen, if it's a framework, I want to be able to have a capability to make it behave exactly how I want it to behave. And it really gets to the concept of generalization over specialization, right? So I'm sure you're familiar with that any specialized solution, by definition, will always be better than any generalized solution, right? I mean, it may actually be not better because you wrote a bad code, but by definition, if you're trying to address a very special use case, that particular code will execute better than a general code with some framework, right? So, and what we were investigating at Hortonworks is various different ways, especially from some of the concerns or some of the questions that came from our clients, and how we can extend Spark, and how can Spark interact with a variety of different internal systems within the enterprises, as well as some of the native Hadoop features and so on. So, so here's a couple of points about why would you want to extend Spark. And the primary one we investigated is integration of Spark with the native Yarn features. And this is actually very interesting, because for me, one of the benefits for that was, I mean, we actually published a blog about this, and you can read it from last year's in Hortonworks blogs, you can find it. But one of the interesting things that, you know, kind of hidden treasures of Yarn is that, you know, the Yarn shuffle has this very interesting side effect, right? Which, why shouldn't I be able to benefit from it if I can, right? If this satisfies my use case. So for example, in Yarn, the shuffle data, when it comes into you on the second stage, it actually comes as a key values. So the values are already grouped. So if you, in Spark, if you say group by, you can actually delegate this operation to be sort of a no-op, because the data has already been grouped for you, right? So you don't have to do that. In Yarn, the data that comes out of the shuffle comes sorted, right, by key. And if that satisfies you, why shouldn't you just benefit from that, right? So there's a lot of so in the big data world, there's a lot of little things, little hidden treasures that we have, whether we're working with a major system like Yarn, or whether we're working with some proprietary code that we have. We always want to be able to, you know, you already admitted you like the API, but imagine if you had to change this API constantly to, you know, interact with this system or that system, that the whole comment about unified API would go away, right? So you don't want to create a Yarn API versus Mesos API versus something else API, right? So you want to have a unified API, but you want to be able, this API, to work together with a variety of systems. So, and that's sort of what I was doing. So, so I guess I've built, for as much as I could, the case that, you know, there should be ability to extend Spark. And the reality is there are abilities to extend Spark. So Spark exposes a variety of extension points, as well as quite a few backdoors, right? So we're not going to talk about backdoors today. We don't have time. Although I always like, that's my favorite part, to talk about that. But we'll talk about some of the extension points that are kind of formal extension points within Spark. So RDD. Obviously, RDD is a first-class citizen within Spark, and it's pretty much the recommendation from Spark community whenever we need to extend, like add functionality, override, enhance the existing functionality. RDD is the component that you would extend and integrate with. But what's interesting about saying, okay, well, since every operation is defined in RDD, then I pretty much don't need anything else other than RDD. Well, that's not always true, because RDD allows you to extend based on the type of RDD. But what if you need more information to make certain decisions, some contextual information? And I'll have a little demo for that as well. So in other words, there's also a thing called Spark context, which is that central object, which is where the triggering is actually happening. So every time you say collect or save as text file, all comes down to this one method called run job, right? And if you have a chance to intercept that one, then you'll be able to actually traverse the functional tree and do all kinds of interesting things and make all kinds of interesting decisions. Why would you want to make, or what type of decisions would you want to make? Well, let me give you one example that actually came from one of our clients. They wanted to use Spark, and for a very simple operation, they just wanted to say source.count, right? The interesting thing about their source, it was actually their own proprietary file. Not ORC, not Parquet, not text file, it was their own proprietary file. And in order to count the records in that file, you really don't have to read line by line, because there was no lines. It was a binary file. There was just a header in a specific byte offset that you have to read, and that's it. You would get the information of how many records in the file. There was a lot of other information there, and they wanted to extend, say, listen, we want to be able to, again, use Spark API, but provide different methods, different operations for various different other things about those particular data sets. And I'm going to have a little example of how to do that, or one of the ways to do that. But again, we start looking into how can you intercept the count method, whether you want to do it at the RDD level or whether you want to do it at the Spark context level, because you want to be able to not go through the process of creating custom file readers and creating a lot of code just to get to that header information. You could simply access the system, read the first 8 bytes, and get the information right away, bypassing everything and making it extremely fast, right? So, so this is, again, one of the use cases that we had to work with. Shuffle readers and shuffle writers. So I'm going to finish with a demo of some of the work we did internally within Hortonworks, one of our labs related to dealing with Yarn native features. Once you get really deep, you essentially have to, if you're interacting with a non-Spark execution environment, now you're dealing not just with RDD overrides or something like that, you're dealing with much deeper abstractions. And in this case, for example, if you're dealing with tasks, you have to somehow source your data when it comes to the actual task from Yarn Shuffle and write it back to Yarn Shuffle and so on. So so Spark provides a strategy called Shuffle Reader and Shuffle Writer, and you can, again, provide your own implementation, essentially sourcing your data from whatever it is you want to source it from, or write it to whatever it is you want to write it to. So additional operations, just like I already mentioned, some of them could be based on RDD, some of them could be based on Spark context. So that's a decision that you kind of have to make. So data broadcasting and caching. This is actually a very interesting feature of Spark. So how many are familiar with data broadcasting and caching? All right, so for those of you who are not, so for typical ETL operations, those two abstractions are kind of meaningless because you just went from A to Z and done, right? But when it gets to the MLlib, when it gets to a lot of iterative operations, you may end up referring to the RDD that has already been computed, right, when you're iterating within the loop or something, right? So imagine what happens if you referring to the RDD. RDD was created by another intermediate operation, which was created by another intermediate operation, which was created by another intermediate operation. And what happens is that there's an if statement within each compute method which basically says, listen, check with the cache manager and see if this RDD has already been computed. Because if it wasn't computed, then it has to compute it, which means it has to refer to the previous one, and eventually go back. So imagine you're doing some iterative computation, and some computation, let's say, took 15 minutes. Now you're referring back to the same RDD that was just computed a second ago, and now the whole thing has to recompute itself again, right? So the caching becomes a very important concept within iterative algorithms. Broadcasting is similar to caching, but it's a little different because you're not you simply have a piece of data, some serializable, could be collection, could be just an object or something, and you want to make sure that everybody can refer to this object. So you can either send it as part of the task, or you can just broadcast it to every available node, and then they will use it. So Spark provides these facilities. However, one of the I wouldn't call it oversight. I guess we just haven't, the evolution of Spark haven't gotten to that point yet, and there's already some frameworks out there that attempt to address it. What if you, I mean, it works great within Spark proper, but what if you wanted to achieve the same sharing and the same broadcasting capability, but in the cross-context communication, right? So let's say the RDD that you already cached, and you're able to enjoy the caching part, basically not recomputing within the instance of a single Spark context. What if I submit a second job which actually has the same computation? And what if I were able to somehow uniquely identify that caching, right? Then my context could actually see that somebody else already computed this particular RDD, right? So, and again, it's all doable because all these things, the caching and the broadcasting, they're all strategies, which means you can start already experimenting, and like I said, a lot of people already do, experimenting with, again, for very highly specialized environments, experimenting with ability to cache and broadcast in cross-context, okay? And there's quite a few more. So let's go back to the code. We're doing good on time. So here's, we'll start with a very simple thing. So we have a very simple, in this case I'm sourcing from a parallelized collection, so I just define a collection with 5 elements in it, and I'm just going to do source.collect, and what it's going to do basically give me an array of 5 elements. Absolutely useless job, but you know, gets you kind of from end to end, right? So now, as I described before, the problem here is that the collect will pull all the data into memory, right? So I may not want to do that because while I'm writing this code with a collection of 5 elements, that's fine, but I know that in real life, this will, this particular operation might be on a very large piece of data, and the result could be extremely large, right? So I want to introduce a new method, right, a new operation. So I want to, instead of doing collect, I want to introduce collect to stream, or collect to stream, or collect into iterator, or something along those lines, right? How would I do that? Well, of course, I can, you know, create my new RDD, right, and create a new operation called collect. But the problem with that is that as soon as if I say source.filter, and again, I'm giving away the fact that I've been working a lot with streams, but anyway, again, this code will always do, but the point here is that once I invoke the filter, filter is an intermediate operation. So filter will return a new instance of a different RDD, right? So for example, if I were to somehow create a new RDD where I define a method called collect into iterator, then this method would no longer be visible because it would be a new RDD, right, which is not what my source was. What can we do to address that? In Java, we had proxies, right? So we could wrap and then return proxy, 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 and then introduce a new strategy on the proxy, and as long as we can cast to that, it would work, right? What can we do in Scala? Huh? Implicits, right? So in fact, Scala, Spark already uses implicits for, let's switch back to word count, right? Scala already uses implicit, or Spark already uses implicit, because here's the interesting line of code. If I comment this import statement, all of a sudden my code doesn't compile because reduced by key operation is not visible, because that's the, that comes from the pair RDD functions, which is introduced through implicit conversions when I return a tuple, right? So, or tuple 2, so to speak. Right? So the same thing we can do here. So I created my own X functions, right? So it's an object, right? I define my implicit converter method, right? RDD to my functions, and you know, or X function, whatever you want to call it, right? And I create this class called X functions, right? And in this case, again, this code is just to demonstrate the concept. Obviously, I'm still pulling everything into the collection and then returning it as an iterator. But the point is that you can implement whatever code you want in here. So typically, you would probably write it to a text file and then read it as an iterator from the text file, something that, for example, we do for some of our clients. But the bottom line is, once I have this, I can go back to my code and say import demo that, where is it? X functions. And now I can say, source collect iterator. So all of a sudden I have a new method, and even if I introduce a filter, it would still compile and everything would be fine, right? So now I have automatically introduced the new operations, and this operation actually going to execute, so we can and we got everything working, right? So, but again, it's returning you as an iterator, so now you can build your own method and do whatever it is you want to do. Well, what about if you need, going back to the use case I was sharing earlier, where operations such as count, right? You want to be able to count, but you don't want to delegate to the count implementation provided by Spark. So at this point of time, again, you can still kind of go through the same approach and override the count method. But you can also extend Spark context, but in Spark it's much easier to extend something because you really don't need to extend it. All you need to do is, for example, provide a trait called myContext, right, which extends Spark context. So now what I can do is I can say with myContext, and all of a sudden, so basically for those of you who, again, going back to Java days, for those of you who are familiar with aspect-oriented programming, what this really is basically bytecode weaving, but made as a first-class feature of Scala, right? So, but it's going to be compiling this code into the final class, and what's inside of this code, myContext, is basically an overridden run job method, which in this case, I created this. It's a poor man implementation of determining what was your trigger method. But in this case, what I'm saying here is that if the operation is about counting, if I want to count, then don't actually delegate to run job and just create some count and return it, right? But for everything else, delegate. So now I actually introduce within Spark without, in other words, here my code doesn't really change, nothing from API. I mean, you look at this API and it looks as any other Spark API. But now by understanding and realizing some of the internals within and how Spark works, I can introduce that. So for example, now if I say source.count, right, and run it, we can see, if, at least from the logs, well, processing count, right? And if I say right now source.collect, then it's actually going into a full-blown run job and bypasses all my count logic and so on and so forth. So again, very simple ways that you can extend Spark. Now, why are we, so this is kind of, almost, you have 6 minutes. So, so I kind of showed you various different ways. There's much more, and I can't possibly cover them all. But what I wanted to kind of talk to you quickly about is some of the work we did by integrating Spark with TES, because for certain types of use cases, specifically for ETL, we noticed some potential improvement. First, we thought about some potential improvements, and then we actually realized that there are certain improvements, and we documented them, and I can point you to the blog where we kind of posted our findings. But what I wanted to show you is, again, going back to the word count is, so we've created extended Spark context, provided TAS execution environment, and all these different things that I mentioned before, shuffle readers, shuffle writers. So we created a framework. It's on GitHub. You can go investigate it and play with it. It's basically part of our labs, right? And what is happening there is that, now you can still have the same unified experience when it comes to code. You can still have the same code. But what I'm going to do here is actually, well, believe it or not, it was actually executing on task before. I didn't even notice it because like this, it would be using Spark Local, for example. But because I created this build Spark config, like a factory method, which again, basically, its through configuration is going to bootstrap a different instance of Spark context, right? It still gives to you as a Spark context, right? But what's going to happen right now is it's actually going to execute using Apache Tez, right? And like I said, for certain multi-tenant use cases, we actually were able to get a better resource utilization, and in some cases even better performance than on Spark, and so on. So go ahead.
I missed how you switched to.
Oh, so I'm sorry. It's basically configuration. So I have a factory method to create, and we have, it's one of the things we introduced into Spark. There's a Jira for that. We introduced an execution context, which allows you to actually configure execution context internally. I'm sorry, externally. But the reality, it's the same as picture, like disregard this code and picture that I had something like this, right? It's the same thing, right? You just said we did it. A lot of times you want to make sure, like going back to what I was saying before, like a lot of times I want to avoid text file. I want to avoid collect. I want to be able to define a pipeline and configure the source, the output from the outside. So what we wanted to do with this particular effort is to try to say, listen, I want to define a pipeline, and when it's compiled, packaged, all in a jar file, I want to be able to just tweak the switch and say, all right, try it on test, try it on Spark, try it on this, try it on that, and see what are the pros and cons of each approach, right? Instead of going into the code and say Spark context, Hive context, SQL context, this context, and so on and so forth. So that's the main idea. But putting that aside, it's the same as if I were to do this, right? So basically by doing that, we overridden the run job method and essentially we integrated with the Spark compiler optimizer and created, using the same Spark tasks, but compiling them into the Tez processors and executing them on Tez, right? So again, it's part of our labs. We don't know where it's going to go and how it's going to become, but again, it's not necessarily, the goal for this one was primarily to showcase how you can extend Spark, how you can make Spark behave exactly how you want it to behave. And since, again, we're primarily dealing with the customers who are using Yarn, a lot of this effort was done with Yarn specifics in mind, but at the same time, we're working with other clients who are actually working of integrating Spark with their own execution environment, something that they actually had before even Hadoop, right? So, all right, so I have 2 minutes left. Let me go back to the slides and kind of talk a little bit about Spark on Yarn. So, yes. All right, so yeah, good. So I guess we're a little out of time. So questions? Yes.
Hi, could you share some good practices to debug Spark, particularly on Yarn when you want to scale? For example, you have a workflow that work on a sample of the data in the standalone mode, and it didn't work on Yarn. So how do you debug it?
I didn't quite hear the question. How do I delegate work to Yarn?
Debug.
Oh, I can actually show it to you. You know what? I'll be outside. I'll actually show it to you, and I'll point you to the project. We actually have. So the question was, how do you debug applications on Yarn? One of the things that I did, because again, as a developer, I can't imagine my life when I cannot step through the code. So how many of you are familiar with the concept of a mini cluster? Okay. So that's what Hadoop guys are using for their test cases. So I've taken that code, extracted into a separate project. It's on the GitHub. I'll show it to you where it is. And written in JVM container executor. It's actually all documented, so you can go there and check it out and just use it. And what the in JVM container executor does, basically it's part of the part of the Hadoop configuration when you start the cluster. Instead of using default executor, which will start a new JVM, use the same JVM and we'll start a new thread. So now you can actually, if you start the mini cluster in the debug mode and execute whether Spark code or old MapReduce code, and you put a breakpoint inside of your code, it will stop without attaching remote debuggers or anything else. So it's that easy. I mean, literally, if I had 5 more minutes, I would show it to you.
There's also a runtime debug embedded. We had a slide towards that.
Oh, yeah. So, and then there's a,
This is development.
yeah. So, I mean, I'm going to publish slides. There's more slides that describing some of the Yarn features and so on and so forth, which also addresses that question as well. Yes?
Between the standard mini cluster in for debugging, for unit testing than yours?
I'm sorry?
Is there a difference?
No, it's the same mini cluster that, it's the same mini cluster. I just polished it a little bit, made it more kind of a developer friendly for the purposes of not embedding it into the test, but rather just start it and deploy to it. So in other words, it's like for those of you who live the world of J2E, it's like having a Tomcat. You start it, you deploy application. It's the same thing. You start a mini cluster, and your configuration just points to the file system, to the. So I packaged the file system cluster and the Yarn cluster together. So it's basically a full-blown Yarn cluster with a file system. Yes. Don't fight, guys.
So I had a question. So we have this ETL process which we are running right now using Pig for data processing. So do you think Spark would be a good replacement for that, because there are some complex joins?
Spark replacement for Pig?
Yeah.
That's a very speculative question, I would say. It's, you know, I definitely cannot answer that, because, you know, the real question is, you know, what's going to be adapted more, Spark or Pig or whatever. That's not up to us to decide. We create technologies, we throw it out there, and then the community decides what's. So in other words, you know, for somebody who uses Pig, remember Spark is great if you already went through the effort of learning Scala and kind of committed to that. But Scala is not easy. I mean, you guys all know that, right? So you have Python, you have some, right, well, yeah.
Higher level products, it can run, actually, there is work to implement Pig on Spark. Currently, it just uses MapReduce. So it's not about replacement, it's about transition your Pigs under the Spark when it will be implemented.
But I think I've heard, I agree with that, but I also think I've heard somewhere where it was the other way around, Spark on Pig. So it's an interesting world we're living in, and who knows what's going to end up. And again, don't disregard Java streams, because Oracle has already published a paper on that, so there is a lot of efforts going on there. So, and if it gives you some of the cool features and fluency that Spark gives you, then maybe it'll take a huge market share away from Spark. I mean, you never know. It's just, we have to live and see.
Does Java 8 stream do distributed?
There are efforts. No, Java Stream implementation is not, but there are efforts to make it distributable. Yeah, and Oracle published a paper for that. Yeah. The API looks very similar there.
The API is not just the distribution.
Yep. A lot of questions, that's good.
So I see the huge benefit of using test backend for Spark, especially when it comes to shuffle phase and also container resizing, right? But in the light of most recent releases of Spark, basically 1.3, where you have dynamic container allocation and sort-based shuffle for Spark. Right. What's your opinion on that, on benefits of using TES in this context? I haven't had a chance to profile it, so the only comment I could possibly make is to say they're definitely done something, right? How reliable, how good it is, it needs to be, validated, versus something that Yarn Shuffle has been already existed for quite a while. So that's the only argument I have. Something that already has some miles on it versus something that's relatively new, right? But we're going to have to profile it, and we're going to have to see if it
that we're going to have to improve as well, you know. But you brought up this question, so I just wanted to, I forgot to mention, if you look at, this is the output from executing the same word count on using Tez, so you can see how nicely sorted the output already is without me sorting anything, because that's just a side effect that you were able to enjoy for free by interacting directly with Yarn Shuffle, right? So.
Thank you.
All right. So did I answer the question, or?
I'm not sure, actually. I mean,
yeah. Well, I'm not.
The answer is that we should do evaluation, which is, yeah, that's true for sure.
Yeah. The reason why I don't have an answer.
Yeah. So, but thank you anyway.
Yep.
Good point.
Any more questions? All right, guys. So we're out of time anyway. So thank you for listening. Thank you for sticking around, and I'll be outside in case if.